I'll be starting, Jonathan. Okay, a very good evening, everyone. I believe you guys are doing well. This is Ajay Villa here, and today we are going ahead with one more premium webinar from Jonathan Powers. And before I go ahead with the introduction of the mentor, I would like to check the audio connection and the video uh, from the audience end. Please do respond over the chat so that we can take it further without any lag or without any delay. Quick response over the chat. Okay, great. I believe the audio is perfect and there is no lag. So before we start with the mentor introduction, I believe you might have gone through uh, the content of today's webinar, what we are speaking about. If you haven't, then today's webinar or today's podcast gonna be on vehicle architecture settings. That gonna be spoken by Jonathan Powers, who is currently a mechanical engineer in Tesla. To speak about some words about the mentor. Jonathan Powers has an MS in mechanical engineering and MBA in finance and strategy. Currently, he is working at Tesla as a mechanical design engineer, as I've mentioned. He has experience in many companies like Panther Racing and Honda R&D America and Workhorse Group INC, and he's a co-founder of Nickel Finance also, and many other or say designing knowledge and knowledge about a lot of tools which had brought him to the current designation that he is holding. I believe you guys will utilize this particular session for the most, and if you have any doubts or any clarification, you can get this sorted in this session itself. And the agenda or the split for this session would be initially Jonathan will be going ahead with the presentation that he need to go ahead on the today's topic that we have decided, and later that we'll be going ahead with Q&A session that gonna be totally on the audience end, whatever the questions that you have related to mechanical engineering or related to the field that you are looking for, right? I think John will be a best person to give you a proper guidance and get your doubts clarified on that. So that would be all. Let's not waste much time, and I would be handing it over to Jonathan. Jonathan, it's all yours. You can proceed. Thank you so much for attending, John, again.
Thanks for the introduction, Ajay. You're able to hear me. I'm ready to go.
Great. I think we can start.
All right. So Ajay was so kind to introduce me there. I am Jonathan Powers. I'm currently a vehicle design engineer at Tesla. Today, I'm going to talk to you a little bit about the economics related to choosing some of these key vehicle attributes and architectural features. So you don't need to be an engineer to understand this. This is just how manufacturers choose the type of vehicles they want to make and why they do that. So the agenda, we'll do 35 minutes roughly of presentation and then 20 minutes of Q&A. I'll tell you a little bit about myself, then I'll talk to you about different types of vehicles and the profit margins associated with them. some target customers for these different types of vehicles. Then I'll talk to you about market demand for these different types of vehicles, setting the overall attribute targets for the vehicles based on their customers and the market demand, and then also the overall styling and profiling, which is probably what everyone's most interested in because it's one of the coolest parts in the entire process. 1 second, sorry about this. All right. So a little bit about myself. My name is Jonathan Powers. I'm a vehicle design engineer. This is my BMW. I love cars. I take this driving for leisure primarily. It's a really fun car, and I like to take it out on the weekends, keep it really nice. I'm pretty obsessed with keeping it looking good. My credentials, I have my MBA, my MS in mechanical engineering, and my BS from the University of Pittsburgh. Right here is my college. This is the Cathedral of Learning. It's the tallest educational building in the eastern half of the United States, probably one of the tallest in the entire United States. My experience for engineering, 6 years on Honda, 6 years on Panther Racing, which was a college Formula SAE club. I would say that's the #1 most important club for building cars and getting hired by these OEMs. Honda R&D America's Power Sports division. I designed the 2022 Honda Pioneer with a lot of really other great engineers. And currently I'm at Tesla in product design integration. I'm working on the Cybertruck, which is like one of the most polarizing vehicles. Some people love it. Some people hate it. Personally, I love it. So yeah. My entrepreneurship background includes Nickel Finance. I co-founded Nickel Finance. It's a fintech app, and also Adventure Hound, which is a land sharing app similar to Airbnb, except instead of sharing your house, you shared your property. So enough about me. Let's go into talking about these different types of vehicles because we want to understand why manufacturers decide to create these vehicles after all. So there are many different classes of vehicles. Right now, I've only chosen 6 different types of vehicles. I chose sports cars, luxury SUVs, full-size trucks, luxury sedans, sport crossovers, and sedans. Each one of these vehicles has a different profit margin. So that is the percentage that the manufacturer profits on every sale. So essentially, it's the difference between the sale price and the cost to build it expressed in a percentage. Some of these numbers may be a little surprising to you, but we're going to talk about why they are where they're at. So let's use the Corvette Stingray, for example. The 2020 Chevrolet Corvette C8 was a mid-engine Corvette, the first one ever, and it has a lot of really good technology in it. So the Corvette is actually a low-margin vehicle because this technology is expensive to produce. You can't sell it for that much or people would not buy it. So you have to have a reasonable price on the car, but all the technology that's in the car is really expensive. So let's do some math really quick. About 20,000 Corvettes sold in 2020. The average sale price was $85,000, pretty reasonable. If you multiply 25% by 85,000, it looks like Chevrolet was making about $21,000 in profit on these vehicles. So the cost of goods is the revenue minus the cost of vehicles, cost to produce. The cost of goods is $63,750 to create this car, which is a lot to create a car. Just check the math, divide 63,000 by 85,000, and you get 75% of the value of 85,000. So that means your math checked out. The profit margin is indeed 25%. Just for a visual representation of the different margins of these cars, from left to right, you see here that sports cars are kind of on the lower end of the margins of these vehicles. Now, cars like Ferrari and Lamborghini, those are a lot different than sports cars. Those are exotic cars. So the margins are higher on those vehicles. But generally, sports cars like Porsche is actually one of the best automotive profit margin vehicles. Tesla is one of the best automotive profit margin vehicles. But if you check here, you see that the sports crossover CUV is the highest margin, which might be really surprising. The reason that it's the highest is because you can build them on platforms like sedans that are already existing. All you do is make it a hatchback, make it have a little bit more interior space. All of the underbody structure, powertrains, everything like that is the same. So you don't have all the development costs that go into a new program. You can kind of like save the costs from a past program. So before I move on, I actually, Jay, I actually can't see anybody's responses here, but I just want to ask, does everyone have any idea why I chose these types of cars? Does anyone know why I chose sports car, luxury sedan, luxury SUV, sedan, sport crossover, and truck? Does anyone know the reason I chose these vehicles?
John, yeah, they are able to hear. Currently, they are attending in YouTube. Guys, quick question from Jonathan that why he had chosen uh, the sedan, right?
Yeah, so I can't see your responses. So just think to yourself why you think I chose these vehicles because I'm about to tell you.
So why he had chosen these all vehicles, right? You can respond over the chat.
This is the reason. Sorry, I might have let the cat out of the bag, but the reason is because these vehicles line up with Tesla's historical car lineup in vehicles that Tesla has made in the past, and the vehicles that they currently make here. So Tesla's first vehicle was a sports car. It was the Tesla Roadster. That was in 2008 to 2012. It was very low production volume. There were not many of them made. They were kind of like a flagship, fancy, innovative technological advancement, and everyone loved it. It was so cool. It was built on a Lotus chassis. After the Tesla Roadster, Tesla started making a luxury sedan, which is the Model S, and they still make the luxury sedan to this day. It just recently had a refresh, and it looks really great. The interior is beautiful. The exterior is beautiful. After the luxury sedan, Tesla began making a luxury SUV, the Model X. Many people love it because of its gull wing doors. They open up, or sorry, falcon wing doors. The doors open up and they're almost horizontal with the ground once they're fully opened. Then Tesla started making the sedan, the Model 3. They still make it. It's our highest produced vehicle. We make a ton of Model 3s. And then the crossover. So that's the Model Y. So Model Y will catch up most likely to Model 3. Everyone wants it because it's so convenient. It has a hatchback and has tons of interior space to store. Take your dogs, go camping, whatever. Down at the bottom here are just the locations these vehicles are produced, which is really cool to see. So the Roadster and the Model S have only ever been produced in California. Model X is also produced in California, but Model 3 and Model Y are more global. Model 3 is made in Shanghai. It's also made in Fremont. And then Model Y is going to be made in Fremont, Austin, and Berlin. So these are going to be very world platform vehicles. So the first car Tesla made was the Roadster, and they needed to acquire a very specific target customer because Tesla had no credibility. They were doing something brand new that people didn't know a lot about, which was high tech electric vehicles. So essentially, they needed to come out of the box with something very enticing that everyone would give a chance. You know, if you came out of the box with the sedan, and you wanted people to buy your sedan, that might not be as enticing as coming out of the box with a sports car, little fun car that you can drive. People who buy sports cars usually have more disposable income, so they can afford a car like this. Maybe the car is not as reliable as your average sedan, your average SUV, but that's okay because these individuals, they want to be known for their purchases. They want to have the notoriety of a Tesla. And also Tesla was very strategic because they built the Roadster on the Lotus Elise platform. So the chassis and the frame and the suspension components, all of that was already created by Lotus. And then Tesla essentially retrofitted it with electric batteries and electric powertrain. So while the margin was not the highest on this car, it was probably around 25%. It really set the groundwork and it got Tesla a lot of recognition because it was such a cool car. Now, to compare that to our most recent car, which is the Model Y. The Model Y is very commonly desired vehicle type. It's a crossover. It's a sport crossover. It looks really sporty from the side, from the front, but it has a lot of utility. It has a ton of interior room. Overall, just great shape, good styling. And the vehicle attributes of this car were that it was built on an existing platform already. So it's built on the Model 3 platform. Tesla was able to take the designs that they already had and basically take it one step farther with a vehicle that produces higher margin, most likely. These numbers aren't actual Tesla profit margins. I don't know what the actual numbers are, but the Model Y does definitely command slightly higher selling prices than the Model 3 because it has more features. It's a larger vehicle technically, but the target customers for the Model Y are a lot different than for the Tesla Roadster. So Roadster was going for a very select few individuals who have a lot of influence. Maybe they're wealthy individuals, but the Model Y, this is really a car for everyone. You know, the average family may want a Model Y to go on trips, to take their kids to national parks, to go on road trips. The Model Y needed to be reliable and it needed to make you feel like you were getting a lot of value by buying the Model Y. But the Roadster, not so much. And that's okay because I'm about to show you the differences in the numbers of vehicles that Tesla has sold over the years. So these numbers I was able to just get off of Google. If you just Google, you know, Tesla Roadsters sold, Model S sold, if you just Google these numbers, you can find them. So this is a really cool chart because it shows how important it is to achieve what is called economies of scale. So as you build out your manufacturing potential and as you build out your capability of building cars at high volume, the price per cost or the price per vehicle lowers. So that means essentially your profit margins are going up and your cost of goods sold is going down. So Tesla is able to make sedans, which are one of the lowest margin vehicles, but still achieve a really good profit margin because of automation, because of the factory layouts, because of efficiency, because of these economies of scale. So Tesla started off with this very small market to get the influence, to influence, you know, wealthy individuals who had an influence over society. They had a very innovative niche product. And then with the mission of transitioning the world to sustainable energy, Tesla eventually had to come out with high volume cars. So the only way they were able to do this so successfully is because they started off with those low volume, high price cars. Because even though the margin was low on those cars, because they were able to charge so much for those cars, Tesla, you know, they didn't go bankrupt. They built these expensive cars with a lot of R&D expenses, but they were able to stay afloat. If they would have done that with the Model 3 right off the bat, I am 100% positive Tesla probably would have been bankrupt because trying to build millions and millions of cars right off the bat is not realistic. You have to start small, you have to build up and get practice, and then you have to go at a large scale here. So all of these things that I have just talked to you about, the vehicle, the customer market, the margins, the demand for these cars, all these things play into setting the attributes for these vehicles. So the Model S, we're going to use as an example because it is one of my favorite cars in the world. It's probably my top 3 favorite cars, but it's so useful and it's so utilitarian. Even though it is a little bit expensive, but the attributes for the Model S are pretty much just amazing. I mean, it's a 5-door liftback, 5 seats. It used to be rear wheel drive, no longer is rear wheel drive. Now it's dual motor all wheel drive or tri-motor all wheel drive, which is the Plaid. It does 0 to 60 in 1.9 seconds. The Plaid, pretty insane. So all of these attributes were set at the very beginning of the program. So whenever you're conceptualizing the car, you have to take into account your market research, and you have to say, okay, here's the sector of the market we want to operate in. Here's what we want to achieve, profit margin wise. Here's the customers we want to appeal to. And that's what Tesla did with the Model S. This car pretty much appeals to everybody. It has good range. There's so much cabin space. It doesn't look like it though. It looks like a luxury sedan, but there's 58 cubic feet of storage space inside the Model S, which is pretty crazy. It's a long car, and it's wide too. So it's a large car, but this is an example of attribute setting. So these are all the constraints that engineers design to whenever they start out with a new car. Engineering, you always need to have constraints, because if you don't have constraints, you could design forever, and you would, just be iterating constantly and wondering if you're at the right place. But when you start off with your goals and your constraints, that is how you get to a successful product in a timely fashion. Just to recap the design process, I have talked to you already about some of these things today. So the market study happens first. Then you set the attributes after that. After you set the attributes, you have your concept design, which I'm about to talk to you about. Then you have your detailed design, which is engineering. So that's what I do on a regular basis for my job. I do the detailed design work. And then you have DFM, DFA. I also do that. It's design for manufacturing and design for assembly. And then we have the sustaining part, which is keeping the product operating, keeping the production lines operating. And I can talk to you all about that in a future session. But for this session, we really wanted to talk more about the economics of creating the car, understanding why the manufacturers choose the types of cars they do, and who they're trying to appeal to with those vehicles. So now comes the coolest part, which is the concept design. So the concept design process for all automotive manufacturers is similar, but it's also very different. So this is true. When cars first start off, they are literally sketched on paper. So you could sketch them on paper. You can use a digital pen or brush. And this is how you start off with the very first iteration of the car. As you can see here, this is a Mercedes-Benz concept. I think they have some of the coolest concept vehicle and concept artists in the industry. So after you make the initial sketch, now you have something to build in 3D. So you start in 2D, and then you want to build it in 3D, because in real life, cars are three-dimensional. They have a volume to them. So then what you do is you clay model them. So this can be done by hand. So there's some really talented individuals who are so steady-handed that they can actually make it appear like the car is perfectly symmetric, just with the use of their hand on a block of clay. So they sculpt these clay cars, and they produce essentially very realistic looking cars, sometimes pretty crazy because they're still in the concept stage. So after they produce the clay by hand, what they do is they actually reverse engineer it into 3D CAD. So they'll scan it with a laser scanner, and they will take a point cloud of all of the surfaces, put it into CAD, and then they'll reverse engineer it with parametric surfaces. So that's surfaces that you can change design coordinates. You can change different sketches. So it's essentially editable surfaces. You can edit them. So after they put it in 3D, then they just repeat this process. So you modify it in 3D, and then instead of hand sculpting it, you mill it with a three-dimensional milling machine. So then you have a mill that goes in, and it creates an actually symmetric vehicle. It creates a vehicle that is going to be representative of how the car looks in real life. And that's how the designers, that's how the creative managers, the stylists, that's how they get an understanding of what the car is actually going to look like. Because in CAD, in 3D CAD, when you're designing a car, you don't always get a sense of the size of the car. You get these things, as I call it, the CAD effect. When I look at something, I can't tell if it's large, I can't tell if it's small until you turn on certain viewing aspect ratios. Maybe you turn on perspective view in the CAD software instead of using parallel view. That was, anyone uses CAD in here, you're probably familiar with what I'm talking about. But it's not always the easiest to see the shape or the aspect ratios of things in CAD. So that's why you have to take it back and mill it out of clay. So now we're on we're on step 7. So this is iterative. This happens maybe like 2-3 times. And then finally, we're ready to start and engineer the actual product. So engineering and design are technically different. So design is styling, engineering is the actual design from a mechanical and electrical cross-functional standpoint, which is like bringing the car to life, making it realistic, because a lot of these concept cars can't be actually made. They're just too complex. They would cost too much to make. So the engineering process is what brings them to life. And then even through the engineering process, you still repeat the clay modeling and reproduction process. So we've done this at Tesla where we make small changes to the vehicle, we go and remill it out of clay, look at it, make changes, go remill it. So it's an iterative process. So just want to talk about each one of these individual steps. Automotive design sketches, this is literally what they look like. And I chose Foose Design is my example just because when I was a kid, I loved watching this show. I loved Chip Foose. I thought he was super skilled when it came to sketching out cars. I mean, this looks like a real car, but it's his sketch by hand. So this is what the designers at the OEMs do too. Like at Tesla, we have designers who just sketch all day. They're so skilled. I can never do it. Volkswagen, Porsche, Ford, everyone has these sketch artists that are just so unbelievably skilled. And this is how they start off. They start off with literally pen and paper. So then after they do this, there's multiple ways that they can go forward. They can either, scan this into the computer. They could start sketching digitally in the computer, which is usually what happens. They set some dimensions to it. But then after they do that, you actually have to create this thing with clay. You have to get a 3D sense of the vehicle. So clay modeling first, usually you model it by hand. So this, you could tell this car here on the left, this is an Acura. You can tell by the symbol on the front. I like Acuras. I think they're awesome, like really nicely built, reliable cars. But you can see here, there's 2 different sides to this car. One looks like it's been milled and the other looks like it has been hand sketched. And sometimes they'll do rough milling to get it down to the general size and proportions. And then they will refine it by hand or vice versa, the opposite way around. But ultimately what they're going for is the CNC milled clay. So you see here on the right, this is a Land Rover. It looks similar to the Acura, so it kind of worked out. But this is the clay actually getting milled. And this is from computer-aided design software. So clay models can actually get to the point where they are so realistic. And this is a prime example of that. So this is the Tesla Roadster, and this picture was found online, but it was like one of the coolest pictures that I was able to find. I just Googled Tesla Roadster, and this picture is in the design studio at Tesla. I've actually been down here, and it's like one of the coolest offices that I've ever visited. It's pretty cool to see my managers in this photo. I can't wait to send it to them and say, hey, I found this cool picture of you online. But it's really cool. That's the Tesla Roadster. It's an amazing looking car. I would love to drive and buy one. I don't know when it's going to come out. I don't know the exact dates. I can't tell you any of that, but just know that just by looking at it, it's going to be pretty revolutionary. The performance numbers are going to be amazing. And yeah, this one, I'm not sure, but I know that it's possible this one could be milled out of clay because I have seen cars that are milled out that are milled out of clay that look extremely realistic. All the manufacturers do that because producing a car out of clay is so much faster and so much less expensive than actually making it out of metal body panels with a structure. You could just make a 3D car just right out of clay. Maybe in the future manufacturers will even 3D print it. I'm not sure. That could be an option in the future, but right now clay is kind of like the gold standard here. It's the go-to. So one of the coolest parts, and this happens like on a daily basis with vehicle design, is the 3D and 2D concept modeling tools usage. So yes, that's right. Photoshop is used to edit vehicle concepts. This is a very common practice where someone just goes into Photoshop, they start sketching with a brush, and this is the 2D, 3D brushing that I was talking about earlier. That's just to make small little adjustments. And then those are actually taken into the rendering engine. A very common rendering engine is Unreal Engine, which if you guys are gamers, maybe you play video games that use Unreal Engine. I'm a gamer. I love video games. And that's why I think it's so cool being in automotive design, because you're essentially playing a video game with the CAD model. You're spinning it around. You're going in really close, looking at all the features and fasteners and all the cool components of the car, and then that ultimately becomes a real vehicle. So Unreal Engine is the tool of choice that a lot of manufacturers use because it's very flexible. It's very versatile. You can create custom engines. You can make your own add-ins. So yeah, it's awesome. So this is what I do for a living. So I work on detailed design, which is product engineering. And detailed design uses 3D modeling softwares that are they're a bit more detailed, and they have more dimensional representations of each part. So all of these parts, like inside the vehicle, the structures, all of these parts will get measured out and defined with the detailed design. So the concept design usually is interiors, it's exteriors, but whenever you get down to the detailed design, this is when every single part is modeled to the nut and bolt. So you could literally go in here and find any nut and bolt on the vehicle. And these are the softwares we use. We use Creo, SolidWorks, CATIA, Siemens NX, and there's so many more. But these are just, I would say, probably the 4 best automotive design softwares that people use nowadays. And that is it. That is the presentation. The first of 2 presentations, which is vehicle architecture setting and vehicle design. So that's how they actually set it at the very beginning. And then once they set it, they go in here and they actually detail out the parts and get them to a point where they can be mass produced. But yeah, that is the presentation. I hope you enjoyed it, and I am looking forward to answering any of your questions.
Great, Jonathan. I think that was a great session by you. I believe most of the audience have got a better picture what they need to use or what they need to understand in terms of mechanical engineering or vehicle architecture, right? So, a few questions that the audience have kept in the chat that I would like to ask from my end, and that would be one from Mr. Just give me a minute.
I would also
Yeah,
be happy to go on the YouTube channel as well and respond to messages if you want me to. I could just go on YouTube.
great. You can do that. I'll just share you the link uh, of the YouTube response in the Zoom.
Sure.
Okay. Until
Yeah,
that
just send
time,
the link.
yeah, till the time, the first question is what is the key factors for the designing part in terms of mechanical designing?
The key factors for the designing part in terms of mechanical design. So there's essentially you have your stresses, you have the environment the part is going to operate in. So the loads that are going to be on the part. It has to survive the loads. You have to have a specified life cycle, like time that the part has to survive. Then you have to design it for manufacturing. So you have to design it based on being able to make it. You can't just design anything and snap your fingers and it works. Maybe if the part is 3D printed, you can do that, but it's not that simple for like cast parts, welded parts, stamped parts, milled parts. It's not that simple. You have to design it for manufacturing and have that in mind. So I would say the first part, you choose your material. There's different properties for different materials, and then you set your condition. You have your boundary conditions, which is the forces that it's going to be on it, and then next is how do we make this part. So I would say those are the key factors. But also, of course, third is the appearance. Appearance is very important as well. But appearance is you work with what you have or constraints, and then you add appearance in. Into the mix.
Okay, great. And one more question, that is, what is gigacasting? I think you have used that term in the slide, right? I think few
Yeah,
of them might have a doubt what exactly it is or what is that used for.
gigacasting. Yeah. So gigacastings, Model Y. This is publicly released information, but essentially, the body is cast. So like the structure is just a giant casting. So traditionally, manufacturers use stamped body structures. So they have all these that are stamped and welded together. But Tesla is being very innovative because the casting, the body structure is just one large casting essentially. So they can save a ton of process time and a ton of cost with all the welding machines and all the labor that goes into that just by using one large casting instead. So it's really funny. Elon Musk described this process similar to like a Hot Wheels car. Like if you pick up a Hot Wheels car and you look on the bottom of it, it's pretty much one piece. Like it's just a piece of metal, and that's his goal for real life cars is to make them essentially one piece. So yeah, it's a really cool concept. Good eye picking that one up.
Great. I think that was from Mohammed Hanis. I think you received your answer on that. Which brings to the next question. What is the current trend in EV, in electrical vehicle designing, or else it might be related to product also, right?
Sorry, could you say that question one more time?
Yeah, so that was what is the current trend that is being followed in electrical vehicle industry, in terms of it might be in Tesla or it might be in some other companies also.
The current trend you asked.
Yep.
So, do you have like more detail of what you mean by the trend? I mean, for
It,
most manufacturers, we just want to
yeah,
encourage mass adoption of these vehicles. I mean, we want as many people to buy them as possible because they are, better for the environment. They're not noisy. You can drive them in cities without, um, you know, noise pollution or actual like air quality pollution. So I think most manufacturers want to get as many cars on the road as possible. Really, is just build out production capacity, um, basically acquire battery production volume. You see these companies just buying mines in these countries and building factories for the actual batteries themselves. So I think that's probably the biggest is just continuing to scale up.
great. And in terms of, let's say, if I say the design of the cars, or it's how it is being portrayed for, I would say, the EV lovers, right? So it might be a new design that has been followed, like what do you say, the Tesla Cybertruck that has been designed, right? Something like that, which is being coming soon in terms of launching, or it's how it is.
Yeah, sorry, Jay. What was that question?
That was like in terms of designing, like Tesla had designed the Cybertruck, right? So which was a unique concept that has been in the market. So anything new that is coming which is similar, or else in terms of the trend, how it is going on?
Yeah, I mean, Cybertruck has, it's been released for a few years now. And this one, the styling of this is just meant to be kind of like in your face, kind of polarizing. You either love it or you hate it. But to me, in person, it looks so amazing compared to like in pictures. In pictures, it kind of looks boxy and like square, but there's so many fine little details to the Cybertruck. As for your as for future products with Tesla, that information can just be found online publicly. So I can't tell any new products coming out, but Cybertruck, it's a big priority. This thing is so cool. We want to bring it to reality. So keep your eye out for Cybertruck, and then for any announcements of future vehicles. But if I were to guess, like just like all the other manufacturers, it'll continue to just be how can these manufacturers differentiate from each other, and how can they meet the customer's needs. So yeah, that's what I have to say to that.
Great, great. That answers, John. And which brings to the next question, that is, what are the cutting edge technologies used in this particular field for, let's say, it might be designing, or it might be battery production or anything?
That's a good question. So cutting edge technologies, obviously the vehicles have to charge fast. So you have really high voltage charging stations that are able to charge the really high voltage batteries in like, crazy fast amount of time. And that's the only way you can enable long distance travel on the road. So doing that, there's a lot of thermal management that goes into the batteries, because that high voltage, it really heats the batteries up when you charge it. So you have to have really good cooling technology. You have to have really good battery cell production methods that are able to dissipate heat. And then you have to have a lot of safety as well, because if a really high voltage battery starts going into thermal runaway, you can't really stop it. It just happens so fast, and the cells continue to ignite and they burn extremely hot. So it's really hard to put out. It's really hard to put out fires once they begin. So I would say safety, I would say battery life, I would say battery charging technology. And then now, I mean, with the gigacasting I mentioned earlier, Tesla is really getting into structural innovation as well. So this is something these manufacturers never would have wanted to do. It's a type of investment that it's extremely forward thinking. It's like I never would have thought of this, and I know that we're probably going to have more innovations like this. So in the future, I know we had a really good innovation with the HVAC system, heating, ventilation, air conditioning, which gave us a really significant amount of range increase. So anything that you can come out with to increase the range is much appreciated.
Great. I believe that answers. And just a follow-up question on that, as you have spoken about the batteries, right? So let's say, what will be the impact of solid state batteries in regards to automobile industry? So that was one of the question from the viewers itself.
Yeah, so solid state batteries, I would say solid state batteries right now, the production methods for them are not fleshed out enough to be able to use them in like a large scale automotive application like this. The reason that we're able to crank the batteries out is because we have these spooled batteries that you can make thousands of them every day, whereas solid state batteries, sometimes they don't use the same production methods that have been being developed for like 10 years. So I would say solid state, it's coming along. Different battery anode and cathode materials is coming along. Right now, lithium ion is obviously very similar, is very common type of battery composition. But yeah, I'm not a battery expert, actually. I'm doing my best to learn more as I work at Tesla, because obviously I get to be exposed to that. But as a mechanical designer, I'm not always designing parts that integrate with the battery. So it's definitely, I'm very fortunate that I do get the opportunity to learn about batteries at a company like Tesla.
Great, John. So, and just a follow-up question on that. That is, I think, too straightforward, I guess. The viewers want to go for Tesla in terms of employment or something like that. So, what they are asking is, what is your area of expertise that had landed you in the job of Tesla, right? What is your skill sets or the things that you have followed so that viewers can also follow the same and it might help them in terms of getting a job in Tesla.
Yeah, so for me, the most valuable experience that I had to getting hired at Tesla was my Formula SAE experience building this race car. And then Tesla also liked that I worked at a company like Honda. So it was educational mixed with experience. So they didn't really care as much about my credentials, like my degrees, like my master's degree. They primarily cared about what I had accomplished and achieved from like a real life perspective. So if your college has a formula team like Formula SAE, or they have any team oriented clubs where you can build, automotive products like ATVs or on-road cars, or maybe like battery-powered long-range vehicles. Anything that you work cross functionally with other engineers that are from a different discipline. That's going to make you look really marketable for the employer.
Oh, okay, great. I believe audience, I have noted down. So more than your degrees or anything, having the skill sets is much important. I think that might lead you to any dream company that you are looking for, right? So that is one quick next question that gonna be, as you know that John, currently EVs are bit expensive side in terms of pocket friendly or something like that, right? So in future, like what do you think it gonna reduce or else in terms of availability of the products or its the parts or its the batteries? How it will work for like coming 5 or 10 years?
Yeah, in the future, the batteries are going to be extremely important for lowering the cost of EVs. Um, I was watching Tesla's battery day a couple months ago, and Elon Musk was talking about like the goals with battery production and how you're able to achieve like better battery technology, better cost. Um, and that's going to be the number one thing for like lowering the price of these cars. Unfortunately, right now the automotive market is just like the entire market is extremely saturated with costs right now. I mean, the whole world prices are rising for a lot of things, so it's going to be hard to get prices back down for automotive manufacturers just because people are willing to pay it. They don't really have a reason to lower the price because people are willing to pay it. So I think in the future you'll see opportunities where there's like really small vehicles, like really small efficient vehicles that are a lot cheaper. I think that'll be super cool to see. And then I think there will be some smaller like commuting vehicles for cities, like little small sedans. That should be really awesome too. So
Great. I believe it would be a bit on cheaper end in the future so that everyone can afford an EV also, which answers that like most of young generation or whoever is currently holding what do you say, petrol or diesel engine vehicles, right? So what they would be thinking is EVs are eco-friendly or else friendly for the environment. Jonathan, any take on this? Any pollution that EV includes, or else is it completely eco-friendly?
yeah, no, there's definitely pollution. I mean, anything humans do ends up having pollution, sadly. I mean, the mines that we operate to get the materials like the cobalt and the nickel for the batteries. I mean, those are extremely detrimental. Just getting the materials out of the ground is really bad. So what we need to do is we need to focus on battery recycling. That's extremely important, is being able to take old batteries, revitalize them, and reuse them essentially. So whether that's from a wrecked car that's considered totaled, you take the battery out, you harvest the battery, or it's from a car that the battery just won't charge anymore because you've put so many miles on it, that the battery won't charge anymore. We need to work on technologies to revitalize those batteries before continuing to just mine for more and more batteries. Otherwise, we're going to be in the same situation that we're in, for internal combustion cars. Internal combustion, you burn all of this gasoline, this diesel, and yes, it's bad for the environment. But at the same time, electric cars, you have to sometimes burn coal to run the generators that store the energy and produce the energy for electric cars. So something that would be really, really efficient would be if you did like a nuclear power plants that only powered electric cars. That could be something that's like super efficient. So that's something I'm looking forward to in the future.
Great, great. And I think there is just a follow-up question on that, which is quite a similar thing that you have mentioned, right? As in terms of battery technology. Uh, the conceptual thing I would say that is battery swapping in terms of electric cars. So currently we are going ahead with a charging booth or else a charging point to get the EVs charged up within 30 minutes or 1 hour or something like that, right? So is there any technologies which is are currently being built in terms of just to go and just pull up a different battery and put it up in your car and run away?
That's a cool question, because I used to think that was the better way to do it. I was like, this solves the problem. And there's companies like Neo doing that. It's a Chinese EV company. They do
Mhm.
like quick swaps, NIO, if you Google them. Um, but I don't think that's necessarily the solution, because then that requires too much effort in the process. You have to unbolt all of the shots, hold the battery on, you have to take the battery down, you have to move it out of the way, you have to pull another one in, you have to put it up. Like there's too many moving parts and too much complexity there, versus just plugging in a vehicle and charging it for 30 minutes, 40 minutes. And I used to think to myself, oh, 40 minutes of charging, that's too long. But then, just getting more realistic, whenever you stop at a gas station, it's sometimes really nice to, go walk around, grab something to eat, take your dog for a walk. Like it's really nice to take a short little break between your travels. So charging is getting so advanced and so quick for a lot of these cars that you can have almost a full charge in like 40 minutes. So I think what is going to continue to happen is just the speed of charging is going to keep happening. I don't think quick swaps for batteries will take off really. I think maybe battery swaps already do happen for batteries bad, like on a pretty regular basis. But like quick swaps, I don't think that's economical to really pursue something like that, unless it was in an environment where there weren't chargers. So then maybe if you had like a really remote charging station, where there's not going to be a large throughput of people trying to charge, maybe you can do like a quick swap. Like if you're in the middle of the desert, and you want to charge, you want to swap your tire out or your battery out really quickly when you're going to the next spot, then maybe quick swaps. But even then, it's like you could just charge it and just take a break. So yeah, that it's a cool concept. I just right now I don't see the economic viability of quick swaps.
Great. As to answer or as to add on that particular point, currently even India is going ahead with having, I would say, proper infrastructure for these kind of charging points or charging stations, right? So I think it might take few years also to get that built up, and after that, in future, who knows? Let's say that might be one of the thing also where swapping technology will also come if it is efficient enough, right? So that is one. And as Jonathan, as you are into F1 and you follow F1 designing and you are enthusiast on that, right? A quick question from my end, personally. Like, what do you think? What is the future of EV in F1, or else what it contributes in F1?
That's really cool, Ajay. I like F1. It's really fun to watch it. I haven't been like too up to speed on it right now, but I think right now you have Formula One, which is like, hybrid internal combustion, like really high horsepower cars. And then you have Formula E, which is like they're testing new battery technologies, they're testing new like safety technologies. Eventually, I feel like they're going to get closer and closer together, Formula E and F1, to the point where the cars will be, you know, fully electric, possibly. Right now, though, the internal combustion engines are just too good. Like the Formula One engines, like we
Yep.
can't really compete with them from electric, just because like the power created by these tiny little internal
Right.
combustion Formula One engines is just like mind blowing. I mean, it's over 1,000 horsepower for these engines that are like less than 2 liters sometimes. It's just absolutely mind blowing the amount of power created by these internal combustion engines. And then you can fill up the gas tank a lot faster than if you were to do a quick swap or if you were to do a charge. So I think as technology advances, I do think that Formula E and Formula One will eventually just like meld into one. But I think for now, they're going to continue down their individual paths.
Great. I think even I would be eager to see both the cars competing each other. That should be the future, I believe. Which
That'd be
brings,
cool.
yeah, that would be definitely cool, John. So that brings to the last part of the session before we close. John, anything that you would like to tell it to our viewers who are planning to, let's say, enter into EV market, or in terms of designing or battery technologies, what kind of exposure that they will get, what they will be able to learn, what they can contribute, anything that you can share?
Yeah, I mean, for me, I started off like this is gonna sound kind of weird, but I started off when I'm just driving RC cars, and it gets you the concept. You understand the layout of the vehicle from an RC car because you have the battery, you have your, front differential, your rear differential, you have your drive shafts, your axles, and it really helps you to understand kind of like the concept design. And then also just working on things like wrenching on things, taking them apart, putting them back together. It sounds trivial, but that's how you learn the true, concepts and mechanical engineering design, because then you understand why it was built a certain way because it comes apart easier. You can rebolt it up really easy. So I would say that if you can get as much hands-on experience as possible, and then when you're looking to learn about this, really leverage your network. So just go on LinkedIn, go on whatever social media platforms you like to use, and leverage your network. Be transparent about what you want to learn and what you're learning, and just connect with like-minded individuals, because you really get motivation from people who are very, positive and similar thinking. But it's also good to have opposing thoughts, but really just connect with positive individuals. And network, leverage your network, create a nice resume, and market yourself. It's really about, when you go to find a job, you really have to just be able to market yourself and kind of, talk about your accomplishments and, what you bring to the table. So, and then finally, if you want to learn more about batteries, I'm sure there's a lot of really good resources, but the best resource I've ever found really is just YouTube. Like if you just go on YouTube, it's free and you can find like some of the best learning resources on YouTube, and it's fun too. I mean, you can find race cars, then the next video you can find how the batteries are produced. Then the next video you can find yeah, like how Tesla was founded. Like the variety of knowledge on YouTube is just unmatched by anything else. So that would be my advice: is go on YouTube and look up videos until your heart is content.
Great, great. Thank you so much, John. I think you have addressed the audience to the core, and you have answered all the questions that they have asked, and few of the questions that we had noted down also. Thank you so much for your time, John. And before I wind up, audience, I would be adding the attendance link in the chat. You can just fill it up on that, and definitely we would be going ahead with these kind of talks in the future, which might be useful in terms of what exactly that you are looking, in terms of technology, or in terms of designing, or in terms of mechanical field, electrical field, anything it is, right? So we bring you all these talks so that you can build yourself, you can get a better exposure on the industry and all those things. So if you like it, definitely subscribe to the Verzeo channel, and you can go for it. And I would highly recommend you to follow Jonathan Paz or LinkedIn platform, and or YouTube also. He have pretty good videos that he had posted, which might be on skateboards or jet skis and other things. I think definitely you would like it. And yep, that's all from my end, guys. And if you have anything to ask, you can write it down in the chat. You can reach out to us. What was your channels? And we provide pretty much good programs in terms of mechanical. If you are a technical person, in terms of technical programs, also you can stay tuned, and you can check our website. We would be eager to follow these kind of programs that we provide over there. So that's all from my end. Thank you so much, Jonathan. That was great speaking to you, and thank you for addressing our audience. And thank you all, guys, for sparing your time for 1 hour and for hearing it. I believe this had helped you out in terms of what exactly that you are looking for, right? If you like it, definitely click like button, share it with your friends, family members, whoever is looking for this kind of content in the future. And if you have anything interesting to approach with in terms of the topic that you want to hear about, right? So you can definitely let us know. We will get that arranged for you. So that's all from my end. Thank you so much, guys. Have a great evening, and have a great morning to you, Jonathan.
Thanks, Ajay. It was a pleasure. I'll talk to you all soon.
Great. Thank you so much. Bye bye.
Bye.
Thank you, guys. I think attendance link would be there in the chat. You can find it, and if you have liked it, definitely, as I've mentioned, you can subscribe and you can stay tuned. That's all from my end. It's Ajay Billag here, signing off.
Thank you. Visit Verzeo.com, subscribe to our channel to know more. Thank you. Visit Verzeo.com, subscribe to our channel to know more.